Hello students. In my previous video, I have discussed about the inventory models with the probabilistic demand. In my last video, I have discussed about the first model in which instantaneous demand is there, setup cost is zero, stock levels are discrete, and lead time is zero. Today, I am going to discuss model 2, 3, and 4 under the category inventory models with probabilistic demands. Let's discuss model second. This is model second, having instantaneous demand, setup cost zero. Here stock levels are continuous and lead time is zero. In this small model, all conditions are same as we discussed in model number one, except that the stock levels are continuous rather than discrete. Therefore, probability that in model 1 we consider probability as PR. Here in this model we will consider probability FRDL instead of PR, where FR is, what is FR? FR is the probability density function of demand rate capital R. Then the optimal order quantity IMO is determined when the value of cumulative probability distribution is equal to the C2 upon C1 plus C2. What is C1? What is C2? C1 and C2 are overstocking cost and understocking cost, which I discussed in model number one. Now, here we will discuss one example that relates to model number two. Here, a baking company sells one of its types of cakes by weight. It makes a profit of 95 paise a pound on every pound of cake sold on the day it is weighed. That is, penalty cost per unit of undersupply, that is C2, is given as 95 paise, that is 0.95 rupees. It disposes of all cakes not sold on the day they are baked at a loss of 15 paise a pound. That is penalty cost per unit of oversupply, that is C1, is given as 15 paise, that is 0.15 rupees. If demand is known to be rectangular between 3,000 and 4,000 pounds, determine the optimum amount to be baked. Now, the demand is known to be rectangular. In case of rectangular distribution, we have probability density function as 1 upon R2 minus R1, where R1 and R2 are demands. Here demands are given in the question, that is, if demand is known to be rectangular between 3,000 and 4,000 pounds, that is, demand is between 3,000 and 4,000 pounds, that is R1 is 3,000 pounds and R2 is 4,000 pounds. Now, as demand is known to be rectangular, that is, it forms uniform distribution. Therefore, its probability density function is given by 1 upon R2 minus R1, that is 1 upon 4000 minus 3000, that is 1 upon 1000. This is basically probability density function. Now we have to calculate the optimum amount to be baked. That is, optimum value of is given by the formula which we discussed in this model, that is 0 to Im FRDR is equal to C2 by C1 plus C2. 0 to Im FRDR C2 upon C1 plus C2. Now the the demand is between 3000 and 4000 pounds. Therefore, it starts from 3000 to Im. Fr is basically 1 upon 1000 dr. C2 is already given, that is 0.95 rupees. C1 is 0.15 rupees, that is 0.95 rupees. After calculation, we get it as 1 upon 1000 Im 3000. This is 0.95 upon 1.1. We get 1 upon 1000 Im upper limit minus lower limit is equal to 0.95 upon 1.1. After calculation, we get the value as 3864 units. This is the example corresponds to model second. Here all the conditions are same as in discussed in model 1, but the difference between model 1 and model 2 is that in model 2 stoke levels are continuous, whereas stoke levels are discrete in model 1. Now I am going to discuss about the model 3, that is third model. The third model is basically in which demand is changed. We discuss about two models in which demand is instantaneous, and first model is in which stock levels are discrete, and then second model is instantaneous demand and stock levels continuous. Now I am going to discuss model third, in which demand is continuous, setup cost is zero, stock levels are discrete, and lead time is zero. I am not going into derivation part of this model. Uh, After derivation, we will get that the optimum stock level is given by this condition. I am not going into derivation part of this model. After derivation part, we will easily get it out that the optimum stock level in this type of model is given by this condition. Now I am, for better understanding, I am going to discuss one example of this type of models, that is in which demand is continuous and stock levels are discrete. Here the example is the probability distribution of monthly sales of a certain item is as follows. Monthly sales is given, that is range of monthly sale is it is from 0 to 8, and the probability PR of probability PR for sale capital R in each month is given as P node is basically 0.01, P1 is 0.04, P2 is 0.25, P3 is 0.30, P4 is 0.23, P5 is 0.08, P6 is 0.05, P7 is 0.03, P8 is 0.01. The cost of holding inventory is rupees 8 per unit per month. The cost of holding inventory is rupees 8 per unit per month. That is, holding cost is given. Holding cost C1 is rupees 8 per unit per month. A stock of 5 items is maintained at the start of each month. That is, optimum inventory is given as 5 units. If the shortage cost is proportional to both quantity and both time and quantity short, find the imputed cost of shortage of unit item for unit time. That is, we have to calculate the range for C2. Now, range of optimum value, range of optimum value of IM is given by above formula. By this formula, that is summation R is equal to 0 to IM minus 1 PR plus IM minus 1 by 2 summation R is equal to IM to infinity PR by R less than C2 upon C1 plus C2 less than summation R is equal to 0 to IM PR plus Im plus 1 by 2 summation r is equal to Im plus 1 to infinity Pr by r. The least value of C2 is given by the least value of C2 is given by considering summation r is equal to 0 to Im minus 1 Pr plus Im minus 1 by 2 summation r is equal to Im to infinity Pr by r is equal to C2 by C1 plus C2. Now we have all the values of parameter put in this equation. We get summation r is equal to 0. Im is 5, therefore 5 minus 1 it becomes 4. Pr plus 5 minus 1 by 2 summation r is equal to 5 to infinity Pr by r is equal to C2. C1 is 8 plus C2. This further becomes P naught plus P1 plus P2 plus P3 plus P4 plus 9 by 2 P5 by 5 P6 by 6 P7 by 7 P8 by 8 C2 upon 8 plus C2. Now we have all the values of probability starting from P0 to P8 put in this equation. We will get 0.01 plus 0.04 plus 0.25 plus 0.30 plus 0.23 plus 9 by 2 0.08 by 5 plus 0.05 by 6 plus 0.03 by 7 plus 0.01 by 8 is equal to C2 upon 8 plus C2. After solving this, we will get the value of C2 as 216. Similarly, the greatest value of C2 is given by considering this part of the equation, that is summation r is equal to 0 to Im Pr plus Im plus 1 by 2 summation R is equal to Im plus 1 to infinity PR by R is equal to C2 upon C1 plus C2. We have value of all parameters. By putting value, we get R is equal to summation R is equal to 0 to 5 PR plus 5 plus 1 by 2 summation R is equal to 6 to infinity PR by R C2 by C1 plus C2. This becomes P naught plus P1 plus P2 plus P3 plus P4 plus P5 plus 11 by 2 P6 by 6 P7 by 7 P8 by 8 is equal to C2 by 8 plus C2. We will take summation here up to 8 because the range of monthly sales varies from 0 to 8. Now we have all the values of probability. After putting the values of probability, we will get it as 0.01 plus 0.04 plus 0.25 plus 0.30 plus 0.23 plus 0.08 plus 11 by 2 0.05 by 6 plus 0.03 by 7 plus 0.01 by 8 is equal to C2 by 8 plus C2. After solving this equation, we will get the value of C2 as 570.25. Therefore, range of values for the imputed cost C2 is 216 to 570.25. This is one example related with model number 3 in which demand is continuous, setup cost is zero, stock levels are discrete, and lead time is zero. Now I am going to discuss model number 4 in which demand is continuous and stock levels are also continuous. This is model number 4 in which demand is continuous, setup cost is zero, continuous stock levels, and lead time is zero. Again, in this model, all conditions are same as in model 3, except that the stock levels are continuous. Similarly, probability FRDR will be used instead of PR, where FR is the probability density function of demand rate capital R. Then the optimum order quantity is given by this equation, that is 0 to IMO FRDR plus IMO to infinity I am FR by R dr is equal to C2 upon C1 plus C2. Let's discuss one example of this kind of model. Here is the example. Let the probability density of demand of a certain item during a week V given by this function fx. Here function fx is 0.1 when x lies between 0 and 10, 0 otherwise. This demand is assumed to occur with a uniform pattern over the week. Let the unit carrying cost of item in the inventory be rupees 2 per week. That is, C1 is given as rupees 2 per week, and unit shortage cost be rupees 8 per week. That is, C2 is given as rupees 8 per week. How will you determine the optimal order level of the inventory? As the demand is uniform over the week, the optimum level of the inventory IM is given by the formula 0 to IM fx dx plus IM into Im to infinity fx by x dx is equal to C2 upon C1 plus C2. This becomes 0 to Im. Fx is 0.1 plus Im to 10, 0.1 upon x dx is equal to C2 is 8, C1 is rupees 2, and C2 is again 8. This becomes 0.1 into Im upper limit minus lower limit plus Im into 0.1, 1 upon x integration log x. Upper limit is 10, lower limit is Im. This equal to zero point 0.8. This becomes 0.1 Im plus zero point 0.1 Im into log 10 minus log Im is equal to zero point 0.8. After solving this equation, we will get the value of Im as 4.5. Therefore, optimum over optimal therefore optimal order level of inventory is 4.5. This is the example related with model 4, in which demand is continuous and also stock levels are continuous. These are the discussion of four models which lies under the category of the inventory models with probabilistic demand. In uh, in my next video, I will discuss about the inventory models with price breaks. Till then, thank you so much.